Okay, today's topic is 3.4 electrical energy and power. Okay, basically in this topic, what is it that we want to learn is we want to learn how to calculate how much energy is used by electrical appliance or how much energy has been dissipated by resistance. For example, a wire have resistance. So we want to calculate, okay, after let's say 1 hour, you on the current. In that 1 hour, how much energy has been dissipated by the resistance in the wire. So why is it like that? Because we know that wire have resistance. So every time the charge want to pass through the wire, the charge will need to do work against the resistance in the wire. Okay? So this also applies to internal resistance. So in this topic, the first thing that we want to learn is how much energy has been dissipated by resistance in wire, in internal resistance, resistance in wire, okay? And also how much energy has been used by electrical appliance. Alright, after that, what is it that we want to learn is we want to learn how to calculate the power of the electrical appliance. Okay? Alright. So first thing is we need to learn how to calculate the energy. How much energy? So we look at here the relationship between electrical energy, voltage, current and time. So you look at this equation. This equation is equation of potential difference. But you see, this is supposed to be work over charge, right? But here we replace the work with electrical energy. The reason is because the work done by the charge is also the amount of energy that has been used. Okay, so for example, if we have a bulb, okay, let's say we have a bulb. So let's say that every 1 coulomb of charge when passed through the bulb use or do the work of 1 joule. So basically it means that every 1 coulomb of charge that pass through, 1 joule of energy will be transferred to the bulb. And the bulb will also use that 1 joule of energy to produce heat and light energy for example like that. So this 1 joule is the electrical energy that is used by the electrical appliance. So basically it is the same thing. We just change the name from work into electrical energy, just so that it can match with what we are talking about. We are talking about amount of electrical energy used by electrical appliance. Okay? So we change the work into electrical energy. Okay, so since this is the electrical energy and this electrical energy is what we want to find. We want to find how much is the electrical energy. So we can calculate the amount of electrical energy by, from this equation, we do a little bit of modification. We rearrange so that the electrical energy equals to the potential difference multiplied by the amount of charge that pass through the electrical appliance. And then from here, from electric current is the rate of flow of charge. So that means every 1 second how much charge pass through. So this amount of electrical charge that pass through will be equal to the current times the time. So what we do is we substitute this amount of charge into here. Then we can get that the electrical energy will be equal to the potential difference times the current times the time for the charge to flow. Okay? Basically like this, very simple. So electrical energy equals to VIT. potential difference times the current times the time. Okay, so the concept is actually very simple. Okay, the concept, why is it that we take the potential difference times the current times the time, we can get the electrical energy, is actually very simple. For example, this bulb lah, okay, if every 1 coulomb of charge, every 1 coulomb of charge that pass through this bulb do the work of 1 joule, that means the potential difference across the bulb will be 1 volt, right or not? Okay, so it means if 1 volt, it means that every 1 coulomb pass through 1 joule of energy go into the bulb. And if we want to know how much energy has transferred into the bulb, then that means we need to know every 1 second how much charge, how many charge already passed through. So we have to look at the current. So let's say that the current is 1 ampere. So 1 ampere means that every 1 second, 1 coulomb of charge pass through. So you see from here, it's very logical. 1 second, 1 coulomb pass through, and every 1 coulomb have 1 joule. So that means in 1 second, this bulb will get 1 joule. So that is why when we take the potential difference times the current times the time, we will be able to get the amount of electrical energy that transfer into the bulb. And that amount of electrical energy that transfer into the bulb will be equal to the amount of electrical energy that the bulb used. Okay? Any question until here? Alright, continue. Okay, so the SI unit for electrical energy is joule. Okay, same as work, because work is energy. Okay, the relationship between power, voltage, and current. Alright, so what is electrical power? Electrical power is the electrical energy used per time taken. This is something that you already learned last time in Form 3. Okay, thank you very much. Okay, in Form 3, you learned that electrical power or power is rate of doing work. Yes, very good. Rate of doing work. So basically, power means every 1 second you can do how much work. If your power is big, then that means every 1 second you can do more work. And if every 1 second you can do more work, it means that every 1 second you use more energy. Okay? So if the electrical power for an electrical appliance is high, then that means every 1 second the electrical appliance will use a lot of energy. Okay? So electrical power is electrical energy used over time taken. So P equals to E over T. Okay? It's the same thing as in the potential difference. The original equation for power is work over time. But here we change the work into energy. So it becomes E over T lah. Okay. So electrical energy is equal to VIT. So we substitute this inside here, and then we can get power will be equal to VIT over T. So power will be equal to VI. That means you can calculate the electrical power of an electrical appliance by taking the voltage across the electrical appliance multiplied by the current that passes through the electrical appliance. This can also be done for resistance. For example, just now I got say resistance in wire. We can also calculate the power of the resistance in the wire. So all we need to do is we take the voltage drop. Remember yesterday we talked about voltage drop. Voltage drop is the voltage that is taken by the resistance in the internal resistance or the resistance in the wire. Voltage drop. Okay? So we take the voltage drop, we multiply by the current that passes through the wire. Then we can get the power of the wire. Basically, what we calculate is every 1 second how much electrical energy has been used by the wire, like that. Okay? So anyway, this is the equation to calculate electrical power. Voltage times the current. And for different situations, there are situations where we do not know the potential difference or the current, but we know the resistance of the wire, or we know the resistance of the electrical appliance. For example, we know the resistance of the rice cooker, or we know the resistance of the bulb. So we can combine this P equal VI with Ohm's law. Ohm's law, V equal IR. We can combine these two to help us find the power when there is no potential difference or when there is no current, but we know the resistance. So for example, V equal IR, we can substitute into P equals to VI, and then we can get P equals IR times I. Okay, current times resistance times current. So we can get the power equals to the current square times the resistance. That means if the situation is where you know the current, you know the resistance, then you can use this P equal I square R to calculate the power. Or you modify this V equal IR into I equals to V over R, and then you substitute into P equals to VI, so you can get P equals to V over R. Then you can get P equals to V square over R. So this is where you don't know the current, but you know the potential difference and resistance, so you can use this P equal V square over R to calculate the electrical power. Is it compulsory to use this P equal V square R or P equals to I square R, P equals to V square over R? Is it compulsory to use? No. The most important is you know P equal VI, you know V equal IR. Because if, for example, you don't know the potential difference, you know the current, you know the resistance. So you can use the current and the resistance put into V equal IR to calculate the potential difference. Just now don't know, now you know already, and then put into P equal VI, you can still get the power. You get the idea or not? Okay, so it's not necessary to use P equal I square R or P equal V square over R. It's just that if you know how to use these two, it will be more convenient. Okay, more convenient for you. Understand? Okay. Alright. So next, the SI unit for electrical power is watt. Okay, this is the unit for power. Okay, power is energy over time. Okay, the unit for energy is joule, the unit for time is second, so joule per second. Right. Okay, you see, energy over time, this is joule, this is second, so joule per second. So this unit of joule per second is substitute with the unit of watt with the symbol of a capital W. So 1 watt is equals to every 1 second 1 joule of energy used, or 1 joule of work done. Okay, that is what it means by 1 watt. Alright. Let's look at this rice cooker. You see this rice cooker, look at the label, the voltage 220 until 240 volt. You see or not? This is what I'm talking about yesterday. When there are electrical appliances, usually the voltage they have a range from 1 volt, from for example 220 until 240. So that means that even if got voltage drop, okay, when you on a switch, there's voltage drop. That means some of the voltage has been taken away by current, taken away by not taken away by current, taken away by the resistance in the wire, taken away by the internal resistance. But if the voltage that the electrical appliance get is within this range, the electrical appliance can still function normally. Okay, can still function normally. Okay, so you see here, there's also a frequency 50 to 60 hertz. This 50 to 60 hertz is the frequency of the alternating current. Okay, that means this rice cooker function with alternating current. Understand? Alternating current. So alternating current have frequency. If the frequency of the alternating current is 50 hertz, that means it changes direction 50 times in 1 second. Okay, and the label here also says that the watt, it doesn't say power, but it says watt, but actually it's the same thing. The watt is 700 watt. So it means that the power of this rice cooker is 700 watt. And then the voltage is 240 volt. So what is the meaning of this label actually? So we look at here, the label of 700 watt, 240 volt means that the rice cooker can do the work of 700 joule every second when supplied with voltage of 240 volt. Okay, so this is the meaning of 700 watt, 240 volt. It means the rice cooker can do the work of 700 joule every second when supplied with voltage of 240 volt. Get the idea? So we call this as the rice cooker able to function normally. Okay, the rice cooker can function normally. It means that if the rice cooker can get the power supply of 240 volt, the rice cooker can function with the power of 700 watt. This is what we call normal function. So that means that if the rice cooker get the voltage less than 240 volt or more than 240 volt, then the rice cooker cannot function normally lah. This is also the same thing for other kind of electrical appliance, for example, the light bulb. Okay, if the light bulb is labeled with 100 watt, 240 volt, for example, that means if the light bulb get 240 volt, then the light bulb can function with the power of 100 watt. If the light bulb get the voltage less than 240 volt, then it cannot function normally lah. That means the power will be less than 100 watt. You understand or not? Example, okay, let's say that we have a bulb. This bulb is 100 watt, 240 volt. The label of the bulb is 100 watt, 240 volt. So that means that if the bulb can get 240 volt, the bulb can function with the power of 100 watt. If the bulb get the voltage less than 240 volt, then it cannot function at 100 watt lah. It will function at less than 100 watt. Understand or not? Okay? So if it get more than 240 volt, then the power will be more than 100 watt lah. So if it's more than 100 watt, most probably the bulb will damage. Okay, will break lah. Because if the power is too high, that means too much energy go to the bulb, so maybe the bulb will burn lah. Understand? Okay, any question? Okay, so solving problem involving electrical energy and power in daily life. Okay, example. Figure show a circuit that is supplied with a 6-volt battery to light up a lamp. If the current is 0.7 ampere, what is the amount of electrical energy used to light up the lamp for 1 minute? Okay, so we want to find out the electrical energy. So electrical energy equals to VIT. So the potential difference is 6 volt. And then the current is 0.7 ampere. The time is 1 minute. So you must change into second. You must change into second. Please be careful here. A lot of students usually make mistake here. Oh, sorry. I shouldn't have write the V. 6 is only write 6 only, not 6 V. Okay, so you should get 252 joule of energy lah. So that means in 1 minute the bulb use 252 joule of energy. Okay. Okay, next. A fluorescent lamp is labeled 240 volt, 32 watt. Calculate the lamp resistance. So we can calculate the resistance of the lamp because we have the voltage, we have the power. So from P equal V square over R, this is the power of the lamp, this is the voltage of the lamp, so we can calculate the resistance of the lamp. Okay, 32 watt, 240 square. So the resistance is, okay, the resistance is 1800 ohm. Okay, alright. So after that, V, the current flowing through the lamp under normal condition. You see or not? In a lot of the question, you will see the word normal condition, or it says can function normally. What does this mean? It means that the lamp obtain 240 volt. Very good. That means the lamp obtain 240 volt. Why is it that the question want to tell you that the lamp is functioning under normal condition? It is very important for the question to tell you that the lamp is functioning under normal condition. Because if the lamp is functioning under normal condition, then only you can use these two information to calculate. Understand? You get the idea or not? If let's say it doesn't tell you that the lamp is functioning under normal condition, then that means maybe you will think, maybe the lamp doesn't get 240 volt. If the lamp doesn't get 240 volt, then that means the power is not 32 watt lah. Get the idea or not? So you cannot use that information. You cannot use the 240 volt, 32 watt to do your calculation. So it is very important for the question to tell you that, okay, this electrical appliance is functioning normally, or is functioning under normal condition, or it says that the lamp or the bulb is light up normally, or it says that the bulb is light up under normal brightness. All of these words are functioning normally, function under normal condition, light up normally, light up with normal brightness. All of this is basically trying to tell you that you can use this information, 240 volt, 32 watt, to do your calculation. Understand or not? You get the idea? Okay, so the current flowing through the lamp under normal condition. So P equals to VI. So the power is 32, the voltage is 240, and then we can calculate the current. So the current will be, okay, the current will be 0.1333 ampere. Okay? Okay, so number 2C, the electrical energy that is supplied for 3 hours in kilojoule. Okay, so E equals to VIT. Alright, so the voltage is 240. And then the current is 0.1333. The time, it says 3 hours, so that means 3 times 60 minutes times 60 seconds. Okay, then equal to, so you get 345,600, but the answer they want in kilojoule, so you must write in kilojoule. So 345.6 kilojoule. Okay. Okay, you see question. If the question doesn't ask you to write in like standard form or in kilojoule, megajoule, or in prefix, don't write in prefix, unless the number is like really big. For example, like when you are calculating the the topic gravitation, you need to calculate the distance between the earth and the sun and so on. The number is super big. Then you press in your calculator straight away give you the number in prefix. Sorry, not the calculator. You press in your calculator, the calculator straight away give you the answer in standard form. Then you write in standard form the answer. If the answer, for example, the calculator show you the full number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you write the whole thing 1, 2, 3, 4, 5, 6, 7, 8, 9. Please do not change into standard form. Because if you change to standard form, then that means you will need to round off. When you round off, then the accuracy will decrease and then it will become wrong. So I got explained to you already. In physics, we emphasize greatly about accuracy. Okay, in physics, we really emphasize about accuracy. We try to refrain, we try to avoid rounding off as much as possible. Understand? Okay, Alright. Okay, done, Okay, next. The third one. Okay, a coil of heating element has resistance of 80 ohm. If a current of 300 ampere passing through it, calculate the supply voltage. So how much is the voltage supply? You see, you have the resistance, you have the current. So you can use V equals to IR. This is the voltage that the heating element gets. This is the current that passes through the heating element. This is the resistance of the heating element. So 3 times 80 . Okay, 240 volt. After that, the electrical power generated. Okay, don't get confused by the word generated. Please don't think that how is it that the heating element can produce electrical energy? It's not like that. Basically, it means that when it says that electrical power generated, it basically means that how much is the power of the heating element. That's all. Okay, it means how much is the power of the heating element. Okay, that means every 1 second the heating element use how much energy. Okay, so you have the voltage, right? You have the current, right? So you can use P equals to VI to calculate. So the voltage is 240, the current is 3. So you get 720 watt. Okay, so you see I use the voltage. This voltage is come from my own calculation. Actually, we try to avoid to use information from our previous calculation because it can be wrong unless there's no choice. But in this case, there is a choice. For example, in this question, it will give us the resistance and the current. We can use P equals to I square R to calculate the power also, right? So I is 3 square, resistance is 80. So you see, we can also use, and we can also get 720 watt. We can still get the same answer. Okay, so basically you have two choices. You have two methods to answer this question. Either you use P equal VI or you use P equal I square R. But if you use P equal VI, the V comes from your own calculation. So if we have a choice, we try to avoid using the answer from our calculation, because there is a chance that our previous calculation is wrong. If our previous calculation is wrong, then that means it will cause us to lose mark in this next calculation also. So it can avoid. But if you have no choice, then of course you use okay? Get the idea? Okay. Next, see the electrical energy dissipated in 5 minutes. Basically, it means the heating element used how much energy in 5 minutes So energy is VIT. So the potential difference is 240. The current is 3. The time is 5 minutes. So 5 times 60 seconds. You must change into second. Okay, so you get 216,000 joule of energy. So again, this one to calculate the energy, not necessarily you use VIT. You can also use P equals to E over T also can. Right, the power you already have from previous calculation, 720. Time 5 times 60. So you can also get energy equals to 216,000 joule So in this, usually a question in this topic, in this chapter 3 that involve electrical energy, electricity, voltage, current, power and so on, usually the question have many different methods to solve. Okay, there is no one fixed method. There are a lot of different methods you can reach the same answer. Okay, Alright. Any question? Okay, next we want to look at this. Compare power and rate of energy consumption in various electrical appliances. Okay, consumer need to be wise in choosing electrical appliances that provide maximum energy saving. So for example, we have two type of lamp. We have compact fluorescent lamp and we have light LED lamp. Okay, so you see here that the CFL, compact fluorescent lamp, the power is 40 watt. The LED, the power is 12 watt, but both produce the same brightness. LED 12 watt, CFL 40 watt. That means the CFL have higher power than the LED. Higher power than LED, but same brightness. That means the CFL use more energy, but the brightness is the same as the LED. Okay, now we want to compare the cost for 30 days if both are switched on for 12 hours a day. Alright, so how to calculate the cost? Actually, this is something that you learn in Form 3 also but just a little bit of revision just take it as revision. Okay, so how to calculate the cost? First thing is you need to calculate the total of electrical energy that you use already. Right, because the cost is based on how much energy you use. Okay, so you calculate the amount of energy used first. Okay, so the electrical energy in calculating cost is calculated in amount of unit. 1 unit of electrical energy is equal to 1 kilowatt hour. Maybe you will think, what is 1 kilowatt hour? Kilowatt hour is also the unit for energy. You see, power is energy over time, right? So energy is power times time. So basically, if the power that you put inside here, you put the unit as kilowatt, and the time that you put inside here is in the unit of hour, then you get the unit of energy as kilowatt hour You see or not? Okay, so 1 unit of energy, when we calculate cost, we refer to the unit of energy that is used as kilowatt hour. So 1 unit of energy used is 1 kilowatt hour. Okay? Okay, now, so usually the charge or the cost or the price okay, so usually the price, okay, let's say that we put it as 28 cent per 28 cent per unit, okay, 28 cent per unit. So that means every 1 kilowatt hour the price is 28 cent. Okay, so this CFL, how much is the cost? Okay, so first we calculate the amount of energy first. So energy is power times time. So the power of the compact fluorescent lamp is 40 watt. 40 watt changed into kilowatt is 0.04 kilowatt. The time, okay, how much is the time? 12 hours a day. Okay, 12 hours a day. So that means one day 12 hours. How many days? 30 days. So 12 times 30 days. So this is the amount of hours. 12 times 30 hours. Okay, 12 hours times 30 days. This is the total amount of hours where the light is on. So we see that is equal to 14.4 kilowatt hour. So this is the total amount of energy used by the compact fluorescent lamp. So the cost will be how many units? 14.4 units times 28 cents. So you get 4 ringgit and 0.32 lah. Okay, you want to write like that also can. 4.032 ringgit also can, or you round off become 4.03 ringgit also can lah. 4 ringgit and 3 cents also can. No problem one. Okay, no problem. Okay, so this is in 30 days 4 ringgit. So let's calculate for the LED. So the energy used by the LED, the power is 12 watt. So change to kilowatt, 0.012. Make sure that you change, when you convert into kilowatt, make sure you must be careful convert properly, because a lot of students, they careless here. Okay, this is the part where a lot of students make mistake. They careless when they convert the unit. Okay. So the time is same, 12 hours, 30 days. So this will be 4.32 kilowatt hour. Okay, 4.32 kilowatt hour. So the cost will be 4.32 unit times 28 cents. So 1.2096, or you can also write as 1.21 ringgit lah. Okay, 1 ringgit 21 cents also can. Alright, so you can see here that the LED is cheaper lah. Okay, LED is cheaper, although it's the same brightness, but LED is cheaper. Cheaper in terms of the electrical energy lah, cost of the electrical energy. Okay, so why like that? Why is it that we have two different bulb with same brightness, but one have higher power, one have lower power? The reason is due to the efficiency of the electrical appliance, efficiency of the bulb. Some electrical appliance have higher efficiency. So you also got learn about efficiency in Form 3. Okay, how do we calculate the efficiency? Efficiency is useful energy output. This is revision okay. Useful energy output over, yes, very good, total energy input. times 100%. Okay, this is something that you learn in science form 3, not in physics. Okay, but although this is something that you learn in form 3, but question can ask in SPM. Maybe the question will not come out, ask you to calculate how much is the efficiency, but usually the question, it won't come out and ask you to calculate the efficiency, because asking you to calculate efficiency is the kind of question that come out in form 3 science. What is it that they will ask you is, they give you the efficiency, ask you to calculate the energy, and then maybe after that ask you to use that energy to calculate the power of the bulb, or to calculate the voltage of the bulb, or calculate the current of the bulb, and so on like that. Understand or not? And then calculate the resistance of the bulb. This kind of question. So they give you the information in the form of efficiency. Okay, understand? So please, so you need to be able to understand what is efficiency lah. They give you, okay, they say that the efficiency of this bulb is 80%, and then they give you the voltage, current, and so on, and then ask you to give you the voltage, for example, and then from the energy output, and then give you the time and so on, and they want to calculate the resistance of the bulb. Okay, for example like that. Okay, so they mash up, they combine the information, the knowledge that you should already know in form 3, in lower form science, with what you learn in physics, like that. Okay, mix together. Okay, any question? Alright, so suggest ways to save usage of electrical energy in household. Okay, I think this is common knowledge already lah. Okay, like how you say? Common sense knowledge already lah, I believe. Please listen, but still please listen. Okay, for example, okay, adjust your day-to-day behavior, make sure that all lights are switched off, plug removed when the appliances are not in motion. Okay, one thing that I want to point out is this one, remove the plug. Why is it that after switch on still need to remove a plug? If it's after switch off already still got current? Off the switch already still got current? No, off the switch actually no more current. This is a misconception actually, I want to point out. Okay, this is a misconception. Okay, a lot of people still think like that. Why is it got this kind of misconception that after turn off the switch still got current? Because of US. In US, United States, America, the socket. What is the difference between the socket in the US and here? No, it's not about the pin. In the US, they are stupid one. Okay, they have no switch. Understand? The socket have no switch. Understand? No on-off switch. But if you go to the hotel in US, yes, maybe they got switch in US. In hotel, yes, they got switch. But if you go to the normal houses, no switch one in the. That means they want to use the TV, they just plug in. No switch one, plug in. That's why in US there's a high amount of cases where baby put their hand into the socket and die. Okay, it's very common, or the baby put the finger in the socket and then die. So, but still they didn't make any changes. That's the problem with US, okay. Okay, there are a lot of things that they should make changes, but they cannot change due to the political issue and so on. Okay. Okay, I don't want to talk about political thing about US. That's their problem. But the problem is, in Malaysia, we are exposed to culture in US very heavily, right or not? You on TV, a lot of the TV program is from the West, from the US, right? So that is why this kind of program where this kind of knowledge, where okay, you have to pull out. If you don't pull out, the current still got running. For example, like television. Television you off with your remote. After you off your remote, is standby mode, right? Not standby. Standby, that means still got use electricity, right? So in the US, if they want to save electrical energy, they must pull out the plug. If not, it's continue in standby mode. But in Malaysia and other normal sane country, okay? US crazy one, okay? In other country, vast majority of other country, Okay, they have switch, we have switch. Okay, so if you turn off the switch, it's okay already. Okay, there's no more current that flow in your TV. Understand? Okay, right, it's common sense to have switch for the plug, right? Okay, I don't know why the US like that. Okay, but anyway, it's their problem. Okay, so this is misconception. This is misconception. I want to clarify so that you don't continue to share this wrong knowledge with other people. Okay, I really fed up. A lot of books still write this kind of thing. Okay, even if you ask other people, you go YouTube, you see a lot of people still share tips how to save electrical energy or must pull out the plug. Okay, this is totally stupid, not logical. Okay, you off the switch already, there's no more current. Okay, there's no more current. Okay, so and same thing also, if you for example got lightning, you off the switch actually okay already. Okay, off the switch actually okay already. Okay, no need to pull out. But it makes you feel good, then you pull out. Okay, depend on you. But for people that study science, study physics, you off the switch, then it's okay already. Alright? Okay, next, reduce the use of high power electrical appliances such as water heater, clothes, dishwasher, dryer, and so on. Okay, so all of these electrical appliances okay, I tell you how to know which electrical appliance that use a lot of electrical energy. You see, if the electrical appliance can produce kinetic energy, vacuum cleaner, fan, your blender, washing machine, spin one, very fast one. The power will be very high. The power will be very high one, I tell you. Okay? Aircon also use a lot of electrical energy because inside there are a lot of motors. They spin, they compress. Okay? So a lot of kinetic energy. So use a lot of electrical energy. Another kind of electrical appliance that use a lot of electrical energy is the kind of electrical appliance that produce heat energy. Electrical appliance that produce heat energy also use a lot of electrical energy. So, for example, like rice cooker or your water heater and so on. So that's why your water heater, your bathe one, after you finish bathing, you off lah. Because if you don't off the switch, then it will keep on heating. The water cool down and then heat again. Cool down, heat again. So it wastes a lot of electrical energy. So please make sure to turn off. Okay? Understand? So this is how we identify the electrical appliance that use a lot of electrical energy and electrical appliance that don't use a lot of electrical energy. Okay, those that don't use a lot of electrical energy, for example, your TV is moderate lah. TV is moderate because the TV basically just produce light. So actually, so it depends on the size of your TV lah. If the bigger the TV, that means the more light is produced, then the higher the energy consumption. That means the highest energy consumption is at the light that is produced. The electronic part don't use a lot of energy. Same with your phone. Your phone, the CPU, the computer inside, do the calculation, actually use a little bit of energy only. The most amount of energy is used at the screen. Understand? The screen is the one that uses the majority of the power. Okay? Use the majority of the electrical energy lah. Okay? So basically, like those that electronic one, the light don't use a lot of electrical energy lah. But the problem is light, you don't have one light only, you have many light right now. Especially if your house is very big, you have lawn, and then you got light at your lamp post, you got light at your roof, light at the wall, and then in the picture in your house got light shine at every picture. Your stairs also got light. Okay, the floor also got light. Okay, you go to the toilet also got light come out like this. So you know lah, nowadays a lot of people they like to renovate the house, put a lot of lights, right? Okay, here got light, there got light. Okay, everywhere got light. So if you have a lot of light, then of course the amount of electrical energy consumption will be very high lah. Okay, alright. So next, replace filter bulb with energy efficient bulb such as CFL or the LED lah. So nowadays more people use LED lah. LED bulb is more expensive, but in the long run, they save electrical energy lah. Okay, so next, perform regular maintenance for aircon and so on. Okay, when you use your aircon, also you set the temperature to the aircon. The temperature you set to 24 or 25 degrees Celsius. Why you want to set your aircon to 24, 25 degrees Celsius? Because the aircon, when they cool the temperature until reach the set temperature, it will stop and rest. So that's why if you set 24 to 25, this is achievable temperature. It can achieve that temperature. It can cool down the room until 24, 25, can achieve, and then the aircon will rest. So it can save electrical energy lah. But if you set 16 degrees Celsius, can achieve or not 16 degrees Celsius? We are living in Malaysia. It's impossible unless you are in Genting Highland and or Cameron Highland. Then yes, you can reach 16. But generally cannot achieve 16 degrees Celsius. So that means what happened to the aircon? The aircon will keep on working lah. Keep on working. So use a lot of electrical energy. Understand? Okay? And of course, all the other common sense things like, if you on the aircon, make sure you close the door, you close the window, everything, so that the heat from out, you can reduce the heat that from outside that coming into the room lah. Okay? So those kind of things. So I just go through this one very quickly because I consider this like common sense, so you can read this yourself lah. Okay? So any question? So if no question, then that's it lah until here.